main goal today is to learn about forces. And so we're going to learn today that forces are all around us. And we're going to look at this little video. And if you see, here comes a cat. And the cat is smart enough, because it's probably old enough to know that if it pushes, it will move. And so the little child looks at it and goes, well, I can do that too. Now, notice that most babies don't walk very well. And that's because they're trying to get their body to fight off what we call gravity. Gravity is a force that holds us down. And so if you look here, she's getting up and using her skeleton to move it along. And so that's what we're going to learn today, that there's forces all around us and we interact with them. Some of these forces you don't realize you have, but you do. So we're going today look at forces. We're going to look how objects interact with each other, because forces, like I said, are all around us. And when you walk or you talk or you pick up something, forces are at work. We're going to learn a little bit about push and pull. That means gravity is pulling you down, but motion, as we're going to see, pulls you away from gravity. We're going to see that there's positive and negative. So wherever there's a push, there's always a pull. And we're going to go over that for every action, there is an opposite reaction. So if you look at this picture here of the boy tugging at its sister, it is pulling. Now notice that the child is pushing backwards. That's because gravity is saying, well, no, I don't quite want to go that way. So her body goes backwards. Now she's on a hill. And so gravity is what pulls you down. So we're going to learn more about that through lots and lots of examples. And we're also going to see that motion can go faster or slower. And we're going to learn the word acceleration. We're going to see how we can get away from gravity, the forces of gravity. So now let's take a look. Now, all of you have been on what is this called? A merry-go-round. Now notice the mom there is holding the child. Now, why is she holding the child? Well, because when things go around like this, there's another force that pulls you out. And there's a force that pulls you in. Motion is kind of weird. It's making you almost glued on to the surface. So that's why she's holding it, to prevent the child from falling out because of this motion. Now, also, let's take a look at this little wind-up toy. Now, how a wind-up toy works is that you turn around and you storing energy in its gear. If you notice in picture number 2, that gear is twirling around. Now, when that gear, when you let it go, like they're doing in the little video there, the energy continues. But notice that it stops. Why does it stop? Well, if we were in anti-gravity, it would continue, but gravity kind of holds it down and it can't continue. So there's all these forces, even on a silly little toy. Now look at here. Uh-oh, what happened to those 2 little kids? Well, wow, they're falling down because nothing is holding them up. If you notice, the platform there is actually pushing against them. And so their gravity is pulling them down, and the flooring is pushing her upward. Now, if the floor isn't there, what happens? Gravity takes over. So there's all of these forces at play on your body. That's why you have to be careful how you move around. Now, look at this little child. Now, the mother, when she took this video, she made the camera go back and forth, but actually the child is just learning to walk. And so that child has to figure out how their legs and their upper body prevents them, how they can hold it up so they don't fall down. But this is normal. You went through it when you were a baby. If you have brothers and sisters, watch how they are trying to adapt their body to the force of gravity. Sometimes you don't make it. Also, if you think about bicycles, when you're learning how to bicycle, it's usually you do it on four wheels because that helps you to defy gravity a little bit better. But once you learn how moving the bicycle wheels keep you going, then you can defy gravity. Okay, now watch. Oh my goodness, what just happened to that little girl? She's thinking, oh, she'll get wet. But the force of the water, yes, water has force, can pull her up. It's so great, it flips her over. Imagine the force that had to be in that water in order to do that. But then she fell. What brought her down? What's the word? Gravity. So she fell down because the gravity pushed her down. Okay. Examples all over. But not only humans have to contend with gravity, all babies. Now look at this little elephant. It was just born. The mommy needed to pull it up so it has four legs that it has to deal with gravity so it can hold those four legs so it doesn't fall down. And then as it gets bigger, it knows how gravity works and won't have to worry about it. Unless, what happens if you trip? Why do you trip? You fall over something. What's pulling you down? Gravity, because you no longer have that, what we call the center of gravity, to hold you straight up. Now, let's take a look. This is Phoebe Chen. She's going to be helping me today. She's going to show you something about this magical liquid.
When we flip this, why does the green fluid fall down?
Now, why is that wheel turning? Well, if you notice, the green liquid is denser. It has more what we call mass. It's just all packed in there. And it is heavier than the other white liquid. And so it falls down because gravity will pull it down. And then as it's falling down, the way this toy is designed is that it captures it and then it rotates around. So gravity works on everything. Now, some of you know how to do hula hoops. Some of you don't. Now, notice this young girl, she's able to use her hips to move it around just right. But when she stops, what happens? It falls down. What's pulling it down? The force of gravity. So she's countering gravity by motion. And motion is almost like what we call anti-gravity. Motion can prevent gravity from taking hold, but once you stop, gravity takes over. Now, how does a yo-yo work? Now, if you've ever noticed a yo-yo, if you look over to the left, you'll notice that the hand and the yo-yo is going up and down, but that's actually not the right place. Phoebe, will you please show them how a yo-yo really works?
Let's see how yo-yo works. Keep an eye on my hand.
Notice her hand was going up and down. So as she was bringing it up, gravity pulls it down. The gravity on the bottom, as it goes down and she's pulling it up, she's making it spin on itself, and then it recoils. Then it goes down, she stops. And so we have motion in a yo-yo allowing it to go up. That's why a lot of people have trouble with yo-yos, because they have to rewrap that string in order for a yo-yo to work. Okay, now also, how do balls work? I mean, balls don't hit themselves. We have to hit the ball and make it go. Now, notice that young kid in the back, he's grabbing it. What happens if he wasn't there? If he didn't catch the ball, what would happen to the ball? The ball would continue. Lots of our games that we use from baseball, basketball, football, soccer, they all use balls and force behind them. And they're trying so gravity doesn't work on them. Okay. Now Phoebe's going to read you a little story called Mugambi's Moving Moon. This is about a little boy who moves from Africa to America, and he's on the plane and he notices that the moon follows him. And so he wasn't quite sure why that happens. Now, we'll talk a little bit later, but it has to do with gravity. We're going to see that even our Earth, remember, our Earth is spinning on itself. And as it's spinning, it is also the moon is going around the Earth, and we constantly seeing it. So that is called revolving around each other. So let's listen into Phoebe and Mugambi's Moving Moon
by Cassie Fries, animated by Doris Rea and Hagos Tawaldi, read by Phoebe Chen. Mugambi loved living in Africa. There was so much to see and do. Lions, zebras, monkeys, and giraffes, these animals are just a few. But Mugambi was moving, and he had to say goodbye to everything he knew, from the ground to the sky. Goodbye, lions and zebras, I will miss all of you, and monkeys and giraffes, I won't forget you. Mugambi packed his suitcase, he looked up to the sky. Man in the moon, I have to say goodbye. Mugambi was moving to America. He was scared and sad. You'll make new friends, said Mugambi's dad. It was late at night. Mugambi got on the plane. He looked out the window. Things won't be the same. From the plane window, Mugambi got on the plane. The man in the moon, oh, please come with me. Mugambi was really tired, and he went to sleep. He dreamt of Africa, where the monkeys leap. He was in America when morning came. There were many buildings, nothing was the same. There were many people, but no lions in sight. He looked for the moon, but it was not night. Animals live in America, but they're kept in a zoo. Going to visit them is what he would do. Mugambi left the airport, and there was a yellow car. It took him to his new home. It seemed so very far. Mugambi arrived to his home, then he ran to his room. He unpacked his suitcase, 'cause his bedtime was soon. He looked out the window from his new bedroom. He saw his old friend, the man in the moon. The end.
Okay, so notice the moon followed Mugambi. So wait a minute. So how did it do that? Well, first of all, I want to introduce you to a very famous scientist called Sir Isaac Newton. Sir Isaac Newton was a mathematician, but he liked to look at the world and try to figure out why things work. And then what he would do is put numbers on it and try to figure it all out. And so when he saw an apple fall down, as the story goes, he had an inspiration about why does the apple go down? And then he started to realize that there was probably a force. He started to look at other things. And as a force is coming down, he started to realize that there was something called gravity. And other scientists started to realize that this force was all around us. And it was a very important part to how we can cope with things. So one of the things that he was interested in, just like Mugambi, was that how in the world does the moon follow us? And then they started to realize, him and other scientists, that the moon actually revolves around the Earth. And then they started to realize that, well, maybe we revolve around something else that is dense or very, very large and packed together. And that is the sun in the middle. So they started to realize that everything is moving in our universe. We're spinning around or rotating, but we're also revolving around the sun. And the same thing with the moon. And that's why we always can see the moon during either the night or the day. It's not following us. It is attracted to us through gravity. So as we go and see how this gravity works. Now we had a question from the last group, like, well, if gravity is all around us, why don't I feel it? And that's because there's another term called inertia. And see, this red person is trying to push this very, very heavy blue box. Now, he can't do it. He can't do it. He's pushing. Why? Because he's pushing this way. And then there's something that, because it's so heavy, it's pulling against him. And so then what's happening is gravity is pulling it into the earth, so it doesn't move at all. And so this is somehow a reasoning why we don't feel all this spinning around. It's because we have an illusion that we're not moving. But you on Earth right now are moving about 300 miles per hour. But because of this inertia, you don't feel it in our atmosphere. So gravity is a strange thing. So now motion will continue unless stopped. So the boy here is holding it, so you can stop it. And if you hold it up there, it will stay there. But what happens when you drop it? Gravity is then pulling it down. So there's forces at play all over. Now, also on a swing here, sometimes it takes little kids a long time to figure out how a swing works. But if you notice in the little animation, the feet are going up and down, and that's because they're giving motion and they're pushing and they're creating they're trying to use motion to combat gravity. Because why? If you don't do anything, what happens? You just sit there. That's because gravity is holding you up, and the swing is kind of pushing you up and you don't move. To move, you need to move your feet. So you have been learning all about how to move in gravity just by moving your legs. Now, let's take a look at some more things that gravity has to play with. Now, some of you have probably played dominoes or put cards up. And how do you knock them all down? Well, all you have to do is start one and gravity will take over. Now, Phoebe's going to show you a toy that is made to combat or to take advantage of gravity.
These are toys that children played with in the early 1900s. So let's try this big one first. Okay, and now this little one, let's see if it does the same thing.
See, so this is these are designed specifically to use gravity as a toy. Now, if these weren't designed right, or if one side of the little man flopping down is bit or something, it won't work, because this is using the center of gravity. Now, that center of gravity, I haven't mentioned that much. Well, that's the same way a child is trying to stand up from gravity. They're trying to find their center of gravity, where you are balanced, where you're balanced on the surface of the earth. Okay, now here's another example of combating gravity. Basically, marbles will just stay where they are because the earth is pushing against and gravity's pulling it down. And so if you see here, at a different angle, you can make things move in a different way. And that's important for getting things to go into motion. And as we grow older, that's how we learn how a basketball goes in a basket or hitting a soccer ball at the right place. It's through practice and understanding how your body can combat gravity. So let's look at this. Phoebe's going to show us the center of gravity. One of these little dragonflies is broke and the other one is not. Let's see if you can figure out which one.
Let's take a look at this toy here. So if we take this dragonfly, we can get it to stay on the flower like that. But if we take this one, we can't get it to stay. And why do you think that is?
The second one that she did is it's back there, the part of the wings is broken off. And so it isn't perfect. So it cannot balance. Now, you've probably heard that word a lot. And so when the center of gravity, when the force is on you, if you can get it just in the right place, it'll work. But if you don't, it won't work. Now, let's take a look at here. More forces. These are, what are these? This is the game of bowling. The whole idea of bowling is to hit it in the right place where all of them go down. And the amount of force will depend on how it works. So let's look at another example. This is a more ancient game. It's called 9-pin bowling that the early settlers used to use. Let's look at video number 1. Not too much force, huh? Let's look at video number 2 from the top. And you can see the more force you get, the more they will fall down. And so, but the ones that fall down, center of gravity, its balance went off, but the other ones maintained their center of gravity. There wasn't enough force to overcome that. It's just kind of like if you're walking and somebody behind you, somebody big pushes you, what happens? You fall down. Your center of gravity is off and then you fall. In say somebody littler than you tries to push you, you just stand because your center of gravity is good. So your balance is good. Now let's take another game, look at another game of pool. It's the same way. You hit it with a ball. If you hit it at the right place, some of the balls will go in the pocket and others won't. And how do you learn how to do this? It's practice, practice, practice. And it's learning and understanding if you hit it at the right angle, it'll work or it might not work. Okay, now let's take a look at this last concept of acceleration. This is important for if we want to get into outer space, we have to get out of our force of gravity. And so in order to do that, you must accelerate. So let's take, Phoebe's going to show you an example of what acceleration can do. Watch the ball.
Let's do an experiment. Let's see how high we have to put the marble on the ramp to get it to complete the loop. This is level 1. So not quite. Level 2. And level 3.
She had enough acceleration there to go over, because as we fall down, we accelerate. And so that's why sometimes when you're falling up at the top of a rock, an egg won't break. But once you get down to the bottom, it usually will break because there's more forces because of this acceleration as you fall down. Gravity, again, Sir Isaac Newton figured out how fast we accelerate as we go down. Now, this even and uneven forces is balancing. So, on a seesaw, a little cat, 2 little cats can equal a big cat. But if you had one little cat and then a big cat, could you still seesaw? Well, yes, you can move closer to the triangle in the middle. So now let's look at number 2. The red person there is strong as 4 gray people. So the forces are equal. If they're unequal, if the 4 people get more force, what would happen to the red person? He would fall down. Or if the red person is Superman, he can pull them all down and they'll all fall down. Forces are all around us. Now, also a pendulum. What is that? Well, pendulum, have you ever seen a clock? It goes back and forth, the old fashioned clocks. And that's how we used to help our gears tell time. But if you have a pendulum like in number 3, notice that it keeps going and going. So if we were not in gravity, the pendulum would go back and forth forever. But look at number 2. This is what happens on Earth. Gravity will slow it down and it will stop. And so there's all this motion and all this stopping that we have to contend with on Earth. Now, another way is this world is full of push and pulls. Remember the apple from Sir Isaac Newton? But look at this spring. The spring is holding in tension. And so as gravity pulls it down, the spring tries to bring it up. And that's what we call tension. So there's ways physicists and engineers always look for ways to combat gravity, because gravity doesn't allow us to fly. Gravity doesn't allow us to do certain things that we wish we could. Now, when they invented the airplane, they understood, engineers and physicists and people were able to put things together to try to figure out how we can use forces of gravity, how we can do motion, and how we can get up and how we can stay up. We're going to talk about that in a little bit. Now let's look at this toy here. It's called a cup and ball. Basically, there has to be a height where it can go into the ball. So Phoebe, will you show them what a cup and ball is and how they can make their own?
This is a ball and cup toy. So what you're going to try to do is toss the ball and get it inside the cup. So one thing to think about is why we need this string here. And you can actually make this at home too. So you just need a small paper cup, and you can just poke a hole through the bottom like that, and then grab a piece of string or yarn and thread it through the bottom and tie a knot so that you can't pull it through. And then you're just going to tie a little rubber ball or a little toy at the end of it like this, and then you're done. So then you have a little cup and ball.
Phoebe's not too good at it. But this is, you can get good, and it's practice. You got to remember, as the ball goes up, as soon as it goes up, gravity gets underneath. And so you have to predict where the cup would be so you can catch the cup. That's the whole idea, is understanding these forces. Now, let's take a look at an airplane. This is going to be our little activity. So teachers, if you want the kids to work with us, just give them a piece of paper, and that will be enough time that Phoebe can walk through, and they can fold it with Phoebe to make their own airplane. But airplanes are kind of cool engineering. They are basically defying gravity. We have to, in order for a plane to get off the ground, we have to accelerate. So there's a point in which the wheels have to go super fast when an engine has to pull it, and then to use the atmosphere to pull it up. Once you get up to a certain level, you can then almost start gliding. That's why it looks like a bird. Glide like a bird. Man has always wanted to fly like a bird, and now we can. But let's take a look at how we can make our own paper airplane, and then to do an experiment. So what you can do is either fold it with Phoebe, or your teacher has the sheets that you can do on your own. And then I'll show you some experiments that you can do.
To make a paper airplane, make sure you have your worksheet with instructions next to you and a piece of long rectangular paper. To start off, we're going to fold the paper in half with the short end facing us. Next, we're going to open the paper up and grab the triangle corner at the top and fold it down so it meets the center line that we just folded. And do the same thing on the other corner. Next, we're going to grab the side here and fold it in so that this edge lines up with that center line. And repeat on the other side. Now we're going to fold both sides in so you have a long triangle like this. And now to make the wings, fold it over and press down really firmly.
That's why I go fast.
Then flip the plane over and do the same thing on this side. Okay, and the final step is to fold the tips of the wings. So just grab the corner and bring it over. And repeat on the other side. Okay, and now when you unfold the wings, you have a finished airplane.
Okay, so hopefully if you made your airplane, I'm just going to show you some things that you can actually do with your paper airplane to try to see how forces affect you. So here's Phoebe just showing you 3 ways in which you can experiment. Go.
Let's see how gravity affects the flight of an airplane. So when we try throwing it, we are the force that's pushing the airplane forward. So let's try a forward horizontal force. Okay, now you can try throwing the airplane up a little bit. And for our last one, we're going to give it a big push and a big force so you can go outside where you have more space.
So this is an activity that you can probably do outside.